Hello, welcome to our presentation on minimizing the cost of goods sold using the Microsoft stack. So we straight away go on to the presentation. So if we have a specific route for actually how we exactly go about it, we look at the gross profit by category for the last fiscal year, look at category A items with low gross profit, with high gross profit, and other category B items. For category A items with high gross profit, we look at the gross margin, trend and seasonality, look at the safety stock forecasting, and optimize the stocking at each location. We also look at location sales analysis and supplier plus analytics. And for category A items with low gross profit, we look at the benchmark. We set up a benchmark for percentage sales and transaction. Look at markdown pricing, supplier analytics, and similar activities are carried out for the category B and C items. So first of all is that we look at using SSRS. What we have sought to do is look at category items with low gross profit, high gross profit, and other items with category B and C. So these graphs are all being made in SSRS. So you look at ABC categorization. So we have used bubble plots here. So you looked at the sales plot versus the gross profit, and this is the percentage cost of goods sold. So as you can see that as the sales value and the gross profit is increasing, so your cost of goods sold is increasing. So C has got the maximum contribution, but A and B account for approximately 50%. So we are okay here. So then what we do is we go one level down. So we just take the top three items. So we see the top two items of category A. They are actually having it in ascending order. And again, the logical flaw, gross profit, as the gross profit is increasing, the sales value is increasing, the size of the bubble for the cost of goods sold is also increasing. So up to now, we are just fine. But now let's look at it in terms of the gross margin. So you have the gross profit here going up and the sales value going up. And again, this bubble should follow the increasing order. But what we find here is that 205 by 65 actually has a lower gross margin than 175 by 65. So there is an issue probably with this particular item, 205 by 65. So we go on to the next, we look at the purchase value. So we look at the gross profit here and the gross margin here, and we look at the purchase value. So here you see these circle sizes should be the same, and the yellow circle size is more. So you have to probably look at the 205 by 65, the purchase details. Then we next look at the category C item. So you get an ascending plot, which is absolutely great because as the gross profit increases, as the sales value increases, your gross margin should also increase. But here you find that some of these items have got very low gross margin. So are these the category C loss leaders? So that is it for the product manager. When we do the analysis, we find that almost all of them have the same gross margin, right? So as the gross profit has increased, the gross margin has remained the same and the purchase value is increased. Okay. Next, we look at the trend and the seasonality pattern. So we look at for the errors and the spikes and the distribution and this thing. So first of all is we plotted in terms of the date, the sales value. So here we see that there's a certain sales peaking in the last 3 months, right? And the sales actually goes up starting April, May, June, July, August, September, and there's a certain sales peaking. But from here on, we start to use Excel. So what we have done is over the last 5 years, we looked at the seasonality distribution. So it goes here, and this is the plot of the mean square error. And using the Excel solver, we have actually minimized the mean square error by allocating the same weight across the last 5 years. And then we arrive at the seasonality patterns, the seasonality indexes for type A and type B items on a percentage basis by quarter and then by month. Then let's look at the location sales analysis. So within the location sales analysis, what we have here is, what we have done is that we have looked at this. This is the category B item. So we have looked at the stock to sales ratio. So you will look at the opening stock divided by the total sales. So here, so between 3 and 4 is the idle stock for category A and B. So 11.58 means it's overstocked and 1.36 means it's understocked. So if you've got two different locations and here you had 11.58 is overstocked and 1 is understocked, so therefore you need to transfer the stock from one location to another. Then we look at the stock optimization issues. So here we have branch 1, you have the current stock, you have the stock to sales ratio. This is the optimum stock to sales ratio in the minimum, that should be between 3 and 4. This is the gross margin, and this is the forecasted demand for next month. So basically we had to find out how much should be the optimal stock at either of these branches. That means how much should you transfer from one branch to another to maximize the gross profit, and this gross profit will include your gross margin as well as the shipping costs. Then we next look at the forecasting for the next 5 quarters by location safety stock requirements. So what we have done is we've taken these items. This is completely a sample case. This was the base case value, minimum, maximum, the most likely. And when we do the sample mean value, so this is the most probable value that comes in. So if an average anticipated was 18,500, actual average mean is 18,963, and you have a 17.62% chances of actually meeting 18,500 budget, and more than a 95% chance that you'll actually be ending up at 19,796. Then we look at the next safety stock. So you have the past sales and the forecasted. So this is all coming from the Microsoft stack. And then you have the lead time in months. So you have to look at the lead time month across suppliers. This is service level, which is 90%. Lead time demand is the sum of all these three. The standard deviation is the standard deviation of this entire past sales across the last 5 years. The service factor is the reverse and normal distribution of the service level. The lead time factor is the square root of this three, and multiply 1, 2, 3, then you get the safety stock, and the safety stock plus the lead time demand gives you the reorder point. Then let's look at the order cost optimization. Again, product one, you look at the holding cost, the storing cost per unit. So these are actually all derived in the data warehouse. So you need to actually simulate these purchase values to minimize the total cost, the total order and the holding cost. These are the particular constraints which are given to you. Similarly, you have it for the purchase optimization. You have one manufacturer steal this thing, and you can optimize it. The inventory order simulation is like here you take the demand and you actually plot it. You look at the variability of the demand and you follow the S2S ordering policy. That means as soon as the stock value falls below 100, you have to order up. You can order up to 600. And you try and optimize your total cost by assuming that there's a variability in the demand. Thank you very much.